Hello and welcome to my channel, where in this series I cover past VCAA Maths Methods exam questions, providing you with a full work solution, including simple tips and also pitfalls and common mistakes to watch out for. In today's video, we'll be going through question 5 from the 2020 Non-Calc Maths Methods VCAA exam. I'll invite you to pause the video and have an attempt at these questions before I show you the solutions. It's a really good way to learn. You won't get as much out of it if you just see the answer straight away. Great, so start off by going through the examiner's report and some brief notes. So question 5A is out of 2 marks, and the average was only a mark for a relatively straightforward question. And then question 5B, again out of 2 marks, the average for this was only half mark. So, on average, people are only getting 1.5 marks out of possible 4, and there's nothing too difficult with this sort of question. So without further ado, let's jump in. So I'll read the question. For a certain population of the probability of being a person born with the specific gene, SPGE1, is 3/5. The probability of a person having this gene is independent of any other person in the population having this gene. Great, so independence, obviously an important thing to take in. Independent. So really would recommend you guys to underline keywords. I've obviously got this figure as well, which is important to do with this SPGE1. Doesn't really matter what that's called, but some specific gene. They can call it whatever they want. So we've got probability, and we know these probabilities are independent. So part A reads, in a randomly selected group of 4 people, what is the probability that 3 or more people have this specific gene? So hopefully you guys can recognize straight away that this is going to be a binomial distribution with probability of that occurring is 3 on 5. And we know that the selected group is 4 people, right? So n will be 4 as well. Great, that's a pretty good start. So what's this question actually looking for? So I'll write down the expression. So just sort of translating from in words to a form that's probably more familiar. So we know 3 or more. So we need to have greater than or equal to 3. This is great and all, and if this was a calc active exam, you'd probably be able to use binomial CDF. However, being a non-calc exam, we can't take continuous functions, so we need to split this into its discrete components. So we've got probability x is greater than or equal to 3. Well, that's the same as having probability x is 3 plus the probability that x is equal to 4. So if x is equal to 3, that means 3 out of the 4 people have it, and if x is equal to 4, then all 4 out of the 4 have it. Great, so hopefully that's clear so far. So to evaluate this, we need to make use of the binomial formula, and this actually was provided in the formula sheet, so hopefully you guys can see that. I've highlighted it in that red box there, so we can see the probability of x equals x is n choose x, p to the power of x, 1 minus that probability to the power of n minus x. And I'll just add in something that's really sort of crucial to breaking down, because it's great that you've got this formula, but what the heck does n choose x mean, right? So this is really just another way of a simpler notation of writing n factorial divided by x factorial over n minus x factorial. So that's really important to sort of keep in mind as well. Great, so jumping back to this question here, we can work this out just by substituting in these numbers. We've got the probability, we've got n, we've got everything that we need to complete this question. So from here, n choose x, so we know it's going to be 4 factorial over 3 factorial, 1 factorial, and then we're going to have that probability, p, which is 3 on 5, to the power of x, which is 3, and then 1 minus that probability, so 2 on 5, to the power of n minus x, so that's 1. We're going to then add, we're going to have 4 factorial divided by 4 factorial, 0 factorial, and then we're going to have 3 on 5 to the power of 4. Great. So then just simplifying some of these notations. 4 factorial is the same as having 4 times 3 times 2 times 1, etc. Or we could say it's 4 times 3 factorial. So if this is 4 times 3 factorial, we'll see that the 3 factorial in the top will cancel out the 3 factorial on the bottom. So this whole expression here just becomes 4. And 0 factorial, well, is 1. So we've got 4 factorial divided by 4 factorial. So this just disappears and becomes 1. So in terms of finishing off the math side of things there, we're going to have 4 times 3 cubed. 3 cubed is 27 over 5 cubed, which is 125, times 2 over 5, plus 3 to the power of 4 divided by 5 to the power of 4. So that's the same as squaring it twice. So it might be easier to do that. So 3 times 3 is 9, and then 9 squared is 81. 81 divided by 5 times 5, which is 25. 25 squared is 625, or the easier way perhaps would be to go 25 times 5. It's 125, then times 5 again, gets you to 625. Great. Doing the same thing here. So if we look at these two denominators, if we were to multiply them together, we'd get 625 as the combined denominator. We're going to have 27 times 2, which would be 54, and then 54 times 4. So that's like taking 50 times 4, which would be 200, and also 4 times 4, which would be 16. So that's an easier way to just go 54 times 4 is going to be 216 over 625 plus 81 on 625. So that gives us 297 over 625 as the final answer for that question. Great. So the most common mistakes with this question, besides the sort of arithmetic, because obviously the arithmetic might be a little bit on the trickier side for this question. That's not really a simple fraction per se, so that's where a lot of people tend to lose marks. But really, nothing that bad. And the other part where people lost marks were incorrectly sort of recognizing that it's also the probability of all 4. A lot of people would just sort of worked out this probability that x was equal to 3. So, great. Moving on to question B. In a randomly selected group of 4 people, what is the probability that exactly 2 people have the SBGE1 gene, given that at least one of those people has the gene? Express the answer in this form: a cubed divided by b to the power of 4 minus c to the power of 4, where a, b, c are elements of z plus. So that means they're positive integers. That's really sort of important to take in, that they are integers, and that, a lot of people would probably get some fractions and leave that as the answer. So it's really important to have an understanding of what that means, besides this, in addition to this specified form that it's sort of referring to here. So I'll just circle that. Great. So what's the question actually asking? It's asking, what is the probability that exactly 2, so we want probability that x is equal to 2, given that at least one of those people has the gene. So you want at least one, meaning x is greater than or equal to 1. So to work this out, hopefully you guys remember the conditional probability rule that states if we have probability of event A given B, then that's equal to the probability of A intersection B over the probability of what's given, so B. So that's the rule there. So in this case, that's equivalent to probability of x equals 2 intersection with x greater than or equal to 1. Maybe I shouldn't have put extra brackets in there. It's maybe a little bit hard to see, but hopefully you guys get that over what's given. So probability x is greater than or equal to 1. So you might be asking yourself, well, what is x equals 2 intersection with x is greater than or equal to 1? For some of you that might be straightforward, but for others sometimes that can be a little bit tricky to get your head around. So I usually find that this is easiest to sort of show visually with just a simple number line. And if you've got a simple number line, so we know x is greater than or equal to 1, what that looks like, right? So we've got 1 here, and because it's greater than or equal to, we'll make this a closed circle. It's everything greater or to the right of 1. And then we're also going to have a closed circle at 2. So what is the intersection of these two lines? Well, we can see that the intersection, or what's common to both of them, is going to be just this particular point. So that is the intersection itself. Meaning we can re-express this new probability of the intersection is simply probability x is equal to 2. So the whole probability that we're actually searching for is this probability x is equal to 2 divided by the probability x is greater than or equal to 1. Okay, getting there. So we've sort of done a lot of the groundwork now. We're almost ready to start putting numbers in, but there's one more thing I'd like to do before we do that. Let's simplify this. So this is sort of the similar issue we ran into with question A, where we had a continuous binomial, but we had to obviously break that up into discrete values to then work out by hand using the binomial formula. So if we were to do the same thing here, well, that would mean that we need to take the probability that x is greater than or equal to 1 is the probability is equal to 1 plus the probability x is equal to 2 plus the probability that x is equal to 3 plus the probability x is equal to 4. And that would take quite a lot of time, especially for 2 marks. So hopefully you guys are thinking, is there a better way to be answering this? And there turns out there is. So due to the law of total probability, the only event that's not being included here is the probability that x is equal to 0. So instead, let's just say that the probability x is greater than or equal to 1 is 1 minus the probability x is equal to 0. So I'll sort of, if I put brackets around here, we know that's going to add up to 1, right? So that's all we're doing. What you might also notice, now we've got it in this particular form, and I will write it out again for neatness. So we're going to have the probability x is equal to 2 over 1 minus the probability x is equal to 0. That's what we're up to. You can see there's similarities in nature to the form that we're required to express our answer in. The only thing is we need to use the binomial formula a couple of times to work out what these values are, and then a tiny bit of manipulating to get them in terms of positive integers, as the questions are asking us to do. So from here, what are we going to do first? Choose a new color because things are getting a little bit wild. So let's work out the probability x is equal to 2. Just like we did before using that binomial formula, which is in the formula sheet, we're going to have 4 factorial over 2 factorial, 2 factorial. We're going to have the probability of success squared. So that was that 3 on 5 squared, 2 on 5 squared. We've got 4 factorial divided by 2 factorial, 2 factorial. 2 factorial times 2 factorial is just going to be 4. So then what we're going to be left with is 4 factorial divided by 4, which is 3 factorial. And 3 factorial is 3 times 2 times 1. So that would be 6. So we're going to have 6 times 3 squared is 9 over 5 squared is 25. Then we're going to have 2 times 2 is 4, 5 times 5, 25 again. Great, so one more step to sort of bring everything all together. Denominator is 25 times 25. Like the previous question, that's going to give us 625 in the denominator. And then if we take the, multiply all these coefficients here, 9 times 4 is 36. 36 times 6 is 216. Don't be afraid. If you need to, find a little part of your worksheet, and you can do that by hand if you wanted. 36 times 6, and do what you have to do. 36 and then 180 gives you 612. 612. So I used to do that all the time, and you're dealing with numbers that you can't quite do in your head, for at least for most people. So that's don't be afraid just to do some little workings, scribble workings on the side of your page if you need. Okay, great. So that's that part done, and then the only thing left really that we need is the probability that x is equal to 0. Now this is pretty straightforward. At least there's a shortcut to it. So if we think about it in terms of what that means for this question, if x is equal to 0, that means none of the 4 people have this gene. And we know if none of the 4 people have the gene, that means that's going to be, and the events are independent, that's another important factor, that it's going to be 2 times 5 for person 1, 2 times 5 for person 2, etc., etc., 2 and 5, 2 and 5, or of course that would be 2 and 5 to the power of 4. And so we're going to have 2 times 2 times 2 times 2, which will be 16 on 625. Great. So then sort of combining all of that, what do we have? We've got 216 over 625 over 1. And in this case, doing a little bit of a shortcut to maybe save a line of workings, 16 on 625. So all I've done here is I've taken our answer in green, substituted it in there, taken our answer in blue, substituted it in here, and this 1 I've converted to another re-expressed 1 in another format. So that's all I've done, and now we can see that all these terms have a denominator of 625. So if we multiply this fraction, both the top and the bottom, so you can think of it 625 over 625. Because we're doing it to both the top and the bottom, the fraction is not changing, right? This is 1 here as well. But what that lets us do is then have 216 over 625 minus 16. So now we're getting really, really close. We've got positive integers here, except we need it in terms of A, B, and C, where A is the cube of something, or we're going to have to cube it to get 216. B, we have to put it to the power of 4 to get 625. And C, again, is to the power of 4 should give us 16. So hopefully you guys can see here, we've been doing 5 to the power of 4 quite a few times. So we know that this here is going to be 5 to the power of 4. We also know that 2 to the power of 4 gives us 16, so therefore this 16 should be minus 2 to the power of 4. And lastly, if we were to take the cubed root of 216, that would be 6 cubed. Maybe not an obvious one, but our workings before should hopefully provide a bit of a clue. We have 36 times 6, where 36 is 6 squared, times another 6 is that 6 cubed. And we could see that would have given us that 216. So that's the final answer. We've met the sort of condition of this question. The A, B, and C had to be positive integers. They are, and they're expressed to the right indices there. That's really the critical thing. A lot of people that were able to answer this question didn't have it in the correct form. So that was one of the main sort of points of feedback on the examiner's report. Hopefully an exam doesn't take you anywhere near this long, but I really wanted to provide a full breakdown and work through of the question, depending on how strong you are in methods. So hopefully everyone could get something out of this question in this video that I've put together. So if you got something out of the video, it'd mean a lot to me if you guys left the thumbs up and share it with any friends or classmates. If you're new to the channel, then please feel free to subscribe for more content like this in the future. Lastly, I do take question requests, so if you have any specific questions you'd like me to cover on the channel, then please let me know via the comment section below, or alternatively via email at yourmathquestions@gmail.com. Thanks for watching, guys. See you in the next one.